everyone. Let's start today with a new topic. Assembly language. This is there for FYCS SEM 1. Let us start. Assembly language, also called as a microprocessor without interlock pipeline stages. Now assembly is low-level programming language. Here you are going to write a program in coded format, and it will be it uses assembler for, you can say, assembling the program, and it will give you the output. Okay, and here we are using different type of assemblers are there. NASM and MASM are the famous one. Now assembly has an extension of .asm. It is a low-level programming language for a computer or other programmable devices. It uses utility program called as an assembler. Our program is going to be assembled, and the source code will going to generate a object program. Okay, the machine language which is converted by assembler, that file is called as an object program. Okay, now for writing assembly program we have to follow certain format. The assembler directives, here we have a .text, .data section. These two are the compulsory one. In the .text we are going to declare all the segment of your program, whereas in .data section you will be referring your all the labels and the variables which you are using in the program. And .global SYM is an optional one, means you are starting your program. Then when we talk about data definition, here you have a .word. It stores the 32-bit memory words, whereas we have a .half. It is going to store 16-bit. Then we have a ASCII and ASCIIs. This is without null terminate, and this one is with the null terminate. Now this is all the common registers which we are using in the assembly programming: V0, V1, all the accumulators. Then we have a temporary registers and the stack pointers. Now let us see one simple program. Here you can see .data and .text section we have simply declared, but we have not written anything. Then in the .global myMean section we have used two registers, that is temporary register T0 and T1, T1 and T2, and LI stand for load immediate. Now when we talk about this value 0x111, that is hexadecimal value, and this is also hexadecimal value. Okay, so basically what we are doing in the program, we are going to add T1 and T2, and we are storing the addition in $T3. Okay, and then we are simply exiting 10 is the service code for exiting the assembler. Okay, now let's simply run this code. I'll simply copy. For running this you have to install Mars 4.5 version. Now this is your IDE. So here you will be opening a file, new file, and simply paste your file. Okay, so first of all, before running you are supposed to save your file. I'll give the name as T1, and the first step is to compile. For compiling you will press F3. You can see here operation completed successfully, then press F5. Now you can see here the program has finished running, and for seeing the output you are supposed to see here T1 is having this value $T1. You can see here this value is present, correct, whereas $T2 is having this value, and the addition is stored in $T3. Okay, so this is how this program runs. Okay, now this is again one of the simple program. Here we have used data section. Here we have written num1, num2. Now these two are our labels of the type .word, and the value we have mentioned here 5 and 10. Okay, and simply we are adding it and we are printing it. Okay, LW stand for load word. Okay, now this is one of the notation to read the value from num1 variable. We are supposed to mention here $0. Okay, so whatever the value will be there, it will be loaded in $T0, and then num2 का value T1 में चला जाएगा, and then we are adding and we are printing it. Okay, let's see. I'll copy this code, press F3, press F5. Now you can see here $T0 is 5, whereas $T1 is A. A how come? 10 को आप hexadecimal में small a से represent करेंगे and the addition will be 15, so it will be represented using F. Okay. Now after that, see this example. This is very nice example. Now here we are taking two number, num1, num2, and both are of word, and we have initialized to 0. Okay, and then we have taken a label prompt which is of type ASCII, and we are asking user to enter the two numbers. Okay, and then finally we have taken one final label which is of type ASCIIs. Here we have a Z. Okay, and we have simply written is the sum. Okay, then in the dot text section we have started dot global start and text. These two lines are optional. Then we are writing LA. LA is load accumulator, $A0, that is our accumulator, comma prompt. ओके ये जो प्रॉम्प्ट हमारा जो मैसेज है लेबल है वो कहाँ पर लोड होने वाला है? एक्यूमुलेटर में. ओके दिस लाइन इज गोइंग टू लोड द मैसेज इनटू एक्यूमुलेटर. नाउ 4 is the service code for printing the string. Okay, li load immediate $V0, 4. Then we are writing syscall. Syscall is a keyword which we have to write for every, you can say, printing or reading. Okay, so this block was for printing the message, your message, that is please type 2 integers. Then once that message has been printed, user is obviously going to give the integer. Okay, so for reading the integer we have a service code as a 5. Okay, so li $V0. V0 हमारा जो रजिस्टर्स है वो उसमें क्या करेगा? 5 सर्विस कोड पे वो रीड करना है उसे. Okay, then we are writing syscall, and that number it is stored in now $V0, so that we have to store in somewhere else. So we are writing SW. SW is store word, and we are shifting $V0 to num1. Okay, so V0 की value num1 में चली जाएगी. Then we are again reading another number since we have written 2 integers. Okay, so फिर से हमें same code वही लिखना है वापस, and again we are writing SW $V0, num2. So V0 की value num2 में चली गई. Okay, now but this line is not necessary. You can directly use it. Like here I have written load word $T0, num1. num1 में जो भी कंटेंट है वो वापस उसने $T0 में स्टोर किया, बिकॉज आप डायरेक्टली दो लेबल्स को आप ऐड नहीं कर सकते. यू हैव टू यूज रजिस्टर. Okay, that is the problem with assembly. So then after that we are writing add, and we will add $T0, $V0. V0 में हमारे पास जो recent number था, second number, it is present, so by default हम उसे यूज कर सकते हैं. Okay, otherwise आपको यहाँ पे वापस लिखना पड़ेगा load word $T1. You have to take another register. Okay, so directly we can take our main register. Then after that we want to print the sum back. So for printing the sum, one is the service code for printing integer. Okay, whatever the calculation you are doing, or you want to print the integer, in that case you will write the service code as 1. Okay, so load immediate $V0, 1. Then we are again writing syscall. Okay, and then LA $A0, final. Final is our label which we have written here, is the sum. Okay, then हम उसे syscall कर रहे हैं, and then finally 10 is for exiting the system. Okay, now let's run this code. I'll copy. Press F3, press F5. Now you can see here the output. Since here we have written ASCII, Z we have not written, correct? So ये Z ना लिखने से क्या होता है? ये null terminated नहीं होता है. Means क्या, दो यहाँ पर हमने यहाँ पे लिखा है enter ओके, स्लैश इन हमने मेंशन किया है, फिर भी वो टर्मिनेट नहीं हो रहा है, वो नेक्स्ट स्ट्रिंग को भी रीड कर रहा है. दैट इज द रीजन वी आर सपोज टू राइट हियर z. ओके, अगर आप z नहीं लिख रहे हो तो ये नेक्स्ट जो स्ट्रिंग होगा वो उसको भी रीड करने लगेगा. सो अगेन प्रेस F3, प्रेस F5. You can see here. Let me clear this first. Okay, you can see here, please type to integer. So we'll give the value 5 and 4. So the sum is 9 is the sum. Okay, so this is how this program runs. Similarly, you can do one simple example, that is reading a number age from the prompt and then printing it back. ओके, सो हमने यहाँ पे हमारा 4 पे प्रॉम्प्ट को प्रिंट किया है, 5 पे रीड कर रहे हैं, देन उसे डेटा को आपको मूव करना होगा टेम्परेरी रजिस्टर में, एंड देन आप उसे मैसेज को प्रिंट कर रहे हैं, एंड देन 1 मीन्स व्हाट, आप वापस हमारा जो नंबर है दैट इज एज विल प्रिंट इट बैक. ओके, देन आफ्टर दैट now let's do this. Take a number from user and print the square. Okay, and also take a number from the user and print the cube. Okay, for this you can use a common operation, or you can say arithmetic operators, like we have addition, multiplication, subtraction, multiplication, okay, division, so forth. Now here I'm just deleting this. Okay, I'm writing a square is. रीड किया हमने, यहाँ पर मैसेज को लोड कर रहे हैं, एंड देन वी हैव टू राइट हियर मूव A0 T0. सो T0 में जो वैल्यू है वो आप यहाँ पे लिख सकते हैं. व्हाट यू विल राइट हियर, MUL $T0 कॉमा $V0 कॉमा $V0. Okay, so now let's run. Yes, this is simple. We have to simply add 2 lines. That is what we have added. We have simply written multiplication here and rest everything is same. ओके, $T0 में आपने क्या किया, V0 का एडिशन, सॉरी मल्टीप्लीकेशन आपने उसमें डाल दिया. क्यूब डालना होगा तो अगेन आप यहाँ पे एंटर प्रेस करेंगे एंड $T0, और यू कैन से टेक $T1, यहाँ पे लिखेंगे आप मल्टीप्लीकेशन, सॉरी मल्टीप्लीकेशन $T1 कॉमा $T0 कॉमा $T0. ओके, एंड देन आप इसको वहां पर प्रिंट कर देंगे. यहाँ पर T1 को आप प्रिंट करेंगे, यहाँ पर आप T1 को प्रिंट कर देंगे. ओके, so both the programs are very simple. You are supposed to do it. Okay, practice on this. Then after that we have a next topic is conditional expression, also called as a branching condition. Okay, B stand for branch. Then you have a syntax target. Okay, so जैसे हम लोग लूप यूज करते हैं, फॉर लूप, वाइल लूप, डू वाइल लूप, सेम वे हम यहाँ पे ब्रांच स्टेटमेंट यूज कर सकते हैं. सो ब्रांच इफ इक्वल टू $T0 T1 दोनों अगर इक्वल है, देन यू कैन से टारगेट. टारगेट मीन्स वेयर यू वांट टू जंप. ओके, वेयर यू हैव टू मूव. सिमिलरली ब्रांच इफ लेस देन इक्वल टू लेस देन, देन टारगेट पे वो मूव हो जाएगा. Okay, you can see this explanation is mentioned here. Equal to, less than equal to, greater than equal to, not equal to. Okay, B and E. Okay, so this way we can simply use LT, LE, GT, GE and NE. Okay, let's see one sample example. Now in this we are simply checking whether a number is positive or not. Okay, so for that I've taken one label n1 initialized to 0. Okay, and then I'm asking a number from user and हमने pp पॉजिटिव नंबर है इसके लिए एक लेबल लिया हुआ है ऑफ टाइप ASCII. ओके, तो हमने सबसे पहले प्रॉम्प्ट को प्रिंट किया है, दैट इज एंटर द नंबर. देन वी आर रीडिंग दैट नंबर एंड वी आर स्टोरिंग इन n1. ओके, लेबल में हमने स्टोर भी किया एंड देन हम L1 की जो वैल्यू है, N1 की वैल्यू वो हम वापस T1 में पुट कर रहे हैं. रिमेंबर दिस नोटेशन, दैट इज प्रिंटिंग द वैल्यू ऑफ N1. ओके, N1 का जो कंटेंट होगा वो $T1 में चला जाएगा. And then this is optional part. Okay, then we are writing BGTZ. Positive number, obviously it will be greater than 0, correct? So branch if greater than 0, Z stand for 0, which हमारा यहाँ पर in this case we have only one register, that is $T1. Okay, and our target will be LBL text. ओके, टारगेट हमारा LBL टेक्स्ट है जो कि हमने यहाँ पे नीचे लिखा हुआ है, LBL टेक्स्ट यहाँ पे लिखा है. ओके, एंड हम 10 से एग्जिट कर रहे हैं. जब वो ये एग्जीक्यूट कर लेगा, इस लाइन पे आएगा, यहाँ पर एग्जीक्यूट कर लिया तो ये वापस इस लाइन पे आके वो प्रोग्राम एग्जिट करेगा. ओके, अब LBL टेक्स्ट में देखते हैं क्या हो रहा है. ये लेबल में है हमारा, यहाँ पर हम क्या कर रहे हैं, सिंपली PP को प्रिंट कर रहे हैं. PP इज व्हाट, दैट द नंबर इज पॉजिटिव नंबर. Okay, so this is one simple example. Let's run this code. Okay, F3, F5, enter the number. Suppose I'm entering 9. So 9 is a positive number. Okay, so this, it is simply showing you the positive number since we have not written for negative. अगर आपने negative दिया तो वो simply program terminate करेगा. Okay, it will not print anything. Okay, then after that let's see one sample program. This is there for your practical, that is using MIPS, microprocessor interlink pipeline structures, write and test an adding machine program that repeatedly reads in integers and adds them into the running sum. Okay, running sum वो बार बार numbers पूछेगा and आपको वो add करना है, and program should stop it when it gets the input, that is 0. Okay, and at that point it should print the sum. Okay, now this is very simple program. So for that, first I'll show you the running part, how it is. First observe the output of this code. Okay, it is asking for number. I'm giving 5, 4, 3, 2 and I'm entering 0. Now you can see here it will print you the addition 5 plus 4 plus 3 plus 2, which is 14. Okay, so this is how it is going to ask. When you are entering 0, it will terminate the code, otherwise it will be in running mode only. Let's see how it is. So for that I've taken 3 integers, 3 label, N1, result and sum. Okay, now these two are our prompt, you can say message, which is going to be printed in the output window. Then you have a word which is initialized to 0. Okay, now in the text I've written a label. This is our target. Then we are saying, since we have to ask for number again and again, correct? So that is the reason ये जो part है read करना and prompt करना will be written in the target. Okay, and then वो read कर रहे हो आपको तो obviously आपको store करना होगा. So you will move that value into $T0. Okay, and then after that you will add in another temporary register $T1, and then there only you will write BGT, branch if greater than $T0. किससे greater than है? 0 से. Okay, 0 से greater है तो ये ऊपर जाएगा और वापस लूप में, लूप इज अवर टारगेट, ओके, इट विल execute this code again and again. But if this condition is false, then it will come out of this loop and it will print the result and it will show you the addition. ओके, एडिशन क्यों? क्योंकि यहाँ पर भी जो प्रेजेंटली जो नंबर होगा तो वो उसको उसे ऐड करना होगा ना एक्यूमुलेटर में. ओके, सो ऑब्वियसली इट विल डू दिस एंड इट इज स्टोरिंग इन $t3 अनदर टेम्परेरी रजिस्टर एंड हम उसे एक्यूमुलेटर में लोड कर रहे हैं एंड देन वी आर प्रिंटिंग दैट इंटीजर using one service code. Okay, so this is how we are supposed to do this practical. This is very simple one. Okay, now one homework question, we will be doing a practical on factorial of a number. Okay, thank you so much for everyone watching this video. We'll continue in our next class.